Okay, so hi everyone, Senan this side, and in this video we are going to solve this question, that is graph bipartite. So this is, you are given an undirected graph, and what you have to do is basically find is the graph bipartite or not. So what is a bipartite graph? So any graph which can be colored using only two colors such that no two adjacent nodes have the same color. So let's say if I color this as yellow, so these three cannot be yellow. So let's color them as green. So I'll color 1, 2 and 3 as green, but in that case 1 and 2 and 2 and 3 would have the same color. So the output is false. We cannot have any such combinations, right? Let's say I color one as what? Yellow, and in that case this 0 and 2 can be green. So if that is the case, these two elements are adjacent and they cannot be both green. So again, this is false. You can try any possible combination, this would not be the case. But if you look at this, so if you have this, you have this like this, right? So if you color this yellow, you can color these two green and this as yellow, and it would satisfy the constraints of a graph being bipartite. Now if just think of it, if your graph is a tree or maybe a forest, disconnected trees, so in that case that would always be a bipartite graph, because the only case we are getting some trouble is when we are having some sort of cycle. So because two paths could have dictated two different possible colors for the same node, so that is where the problem is having. So if the graph is a tree or a forest of trees, the graph is, by definition you can say it's bipartite. The only way that you are having problem is when you have loops, and in this case you see, if you have odd length loops you have a problem, if you have even length loops you don't have a problem. So let's look at how do we do this. Let's look at this function. So the number of vertices is basically graph dot size, and let's create a visited array of size v with initialized with all the values as -1. Why -1 and not 0? We'll look at in the code, and somewhere it is also written that the graphs may not be connected, so that is why we have to do this call in a for loop. So this is basically BFS for the explanation part, and now let's look at the BFS code. So BFS is what? Using a queue data structure. So I take the queue. So BFS, the signature of BFS is taking the node, taking the visited array and taking the graph. So what does visited array store? So the visited array is basically storing the color. So if it is not -1, it is either 0 or 1. That is how I'm keeping track of the color of this node. Now I create a queue, I push this node and I initialize the color as 0. Let's say 0 is yellow and 1 is green. Now I do the BFS traversal as normal. So int top, I take the topmost element, I remove that topmost element and I go to all its neighbors. So while visiting all its neighbors which are not visited before, what I do is I check. So not I don't check, but I assign the color to this element as opposite of what is the parent node of this lm child. So if this is 0, the visited array of lm would have 1, and if this is 1, then this would have the value 0, and I push this element into the queue. Otherwise, if we know that visited is lm is basically not -1, that means I have somewhere along the line I have visited that element and I have assigned some color to it, right? And if that is the case, I would check if the color that I had assigned it is the same as this parent node of this lm. So if these two have, so these basically mean these are adjacent nodes, and if they have the same color, that means this is a false combination, so we return false. Otherwise, if we never go into this if statement, else if statement, we return true because we never found anything. And if you think, if you had a tree, right, this condition would always be true because you can never visit the same node twice. Okay, so the next thing is, yeah, this is fine and this is very well working. So this was run using the DFS code, but let's see. What I did was to change this queue to a stack, nothing else. So that would be the depth first search traversal. Maybe the order of depth first search would be the reverse as what you've generally seen, rather than going from left till you reach a leaf node or something like that. You go towards the right, because we are pushing the elements in the reverse order. But still, that is a DFS traversal. So the code is exactly the same. I have not even changed a single thing apart from that, where I had written q, I had written st, and this q is stack, and stack has a top function, not a front function. And literally this in the previous BFS it was queue, now it is stack. I have not changed anything, it's still the same DFS and it's still working fine. So this was the code of writing to check if a graph is a bipartite graph or not. And I have shown you two solutions, BFS and DFS, and both are the iterative version of BFS and DFS. So hope you enjoyed this video, and thanks for watching. Okay, so sorry, the time complexity and space complexity would be the same as DFS or BFS, which is big O of V plus 2 times E. And yep, you know this already, so bye again.